Why can you instantly recognize a three-line sketch of a bull, yet a state-of-the-art AI struggles to understand the exact same drawing? We possess a secret superpower, visual abstraction. We don't just see what is there, we see what is relevant. But how does our brain decide what to keep and what to throw away? And why is this human gap the biggest hurdle in artificial intelligence today? To understand, we have to look at the tools we use to see the world. What if the tools you use to understand the world are actually shaping your brain? Imagine a chaotic, noisy cloud of real-world data points. Humans didn't just discover math. We invented tools like the number line and coordinate planes to make the invisible visible. These aren't just symbols, they are mental lenses that allow us to solve millennia-old puzzles by turning impossible arithmetic into simple geometry. If we don't understand how these lenses work, we can't build better ones for education, science, or the future of AI. Let's look at how we apply this. When you draw a bird, do you draw every single feather or just a few lines? How does your brain decide? Researchers found that if you are drawing a bird to communicate with someone who sees a collection of similar birds, you use fewer strokes. We don't draw to be photorealistic. We draw to communicate. Visual abstraction is a strategic choice based on context. We zoom in on what matters for our specific goal. But abstraction isn't just about simplifying. What is the difference between a picture of a machine and a diagram of how it works? There are two ways to use our mental lens. A depiction focuses on visual appearance, the background, the colors, the texture. An explanation, however, intentionally sacrifices visual fidelity to highlight the mechanism, using arrows, motion lines, and emphasizing the causal parts. Human understanding requires knowing how to manipulate and highlight mechanisms, not just observing surfaces. We see the function, not just the form. If we can teach machines to recognize a cat in a photo, why can't they read a simple bar graph? Take this stacked bar plot. A human can instantly tell you the cost of peanuts in Las Vegas. But a top-tier AI often fails this exact task. AI models are trained on pixels, but humans are trained on meaning. Even when AI gets the right answer, it doesn't make human-like mistakes. It lacks our intuitive grasp of the mental lens we use to scan, interpret, and reason with data. This is the massive human model gap in AI. So, what is the ultimate limit of our mental lenses? Let's return to the Picasso bull. We recognize the bull because our brains are hardwired to find the causal and mechanistic essence of a thing. We are not just passive observers, we are active engineers of meaning. We've seen that abstraction is a strategy, that explanations require sacrificing detail for function, and that the future of AI depends on capturing this uniquely human way of seeing. Because in the end, we don't just see the world as it is, we see the world as it works.